So page 462, 9-1, right triangle trig. This is to help you out with your ISAT test. You learned this in geometry, a lot of it. I'm going to teach you more of it today. I'm going to remind you of what you've probably forgotten since geometry. By the way, everything you're going to learn today only applies to right triangles. You can use trigonometry on non-right triangles, but I'm not going to teach that to you because it won't be on anything you're tested on until you get to the actual course called trigonometry. Anyway, so just plain any old generic right triangle, this is what we do. This is how we label it so that everybody can agree on where things go. If you use A, B, and C for the corners, C will always be the right angle. If you use P, Q, and R, R will be the right angle. If you use X, Y, and Z, Z will be the right angle. You understand what I'm saying? Okay, and they'll generally be 3 letters in sequence, whatever they use. Usually it's A, B, and C. C will be the right angle. A and B are arbitrary. It doesn't matter where you put the other two. And this is called the right angle. These are called the 2 acute angles. They have to be acute. You can't have 2 right angles and make a triangle because there's 180 degrees to go around. And if you use up that 180 degrees on 2 angles, you got nothing left for the other one. So these will always be the 2 acute ones. The first 2 letters in the sequence will be the acute ones, and it doesn't matter where you put them. Got that? Okay. The sides that are opposite those letters, and by the way, you will always call the corners using capital letters because in geometry you learned that a point is represented by a capital letter. The sides will be represented by small letters that are opposite the big ones, like this. This is little a, and it stands of that side. This is little b, and it stands for the length of that side. And this is little c, stands for the length of the hypotenuse. Another couple of facts you probably already know, but I'm bringing back to your conscious memory. This will always be the longest side. Okay? We call this side the hypotenuse, longest side. That's how we refer to it. We refer to these other 2 that make the right angle as legs. Usually, but not always, but usually there will be a shorter one and a longer one. So we will refer to this as the short leg, call it A. This is the long leg B, and the hypotenuse is C. And you already know how they're related, the lengths of the sides. A squared plus B squared equals C squared. That's Pythagorean Theorem and only applies to right triangles. Yeah, we good? So given any 2 of these, you should be able to find the third. Yeah? Okay. Here's the other. This is where the trigonometry starts, and this is by definition. So don't say, how does somebody figure that out, or how did they come up with that? It's a definition. It's like saying, what do you call that? You say a desk, and you say, why? Well, because we English speakers have agreed to call that particular furniture piece a desk. That's why. It's an agreement. It's a definition. Here's what we will agree on. Whether you agree or not is irrelevant, but this is what we've agreed on as mathematicians. The sine of an angle, and the thing that fits right behind this, and by the way, that's an abbreviation. It's actually SINE. And for heaven's sake, do not expose your ignorance in math and call that sin. Do not say that. That's dumb. This is sine. And will always be, well, what we're doing today anyway, it'll always be the sine of one of the acute angles, never the right angle. So if I say the sine of A, its definition is a ratio. It's something over something else. And the sine of A is, you go to angle A and get your eyes focused there, and then it will be the opposite side over the hypotenuse. So in this case, A over C. I'm going to put out here in general, it's the opposite over the hypotenuse. The cosine is abbreviated COS, and that's the way they put it on the key on your calculator too, cosine. If I stick with angle A, the cosine of A, if that means you focus on this angle right here, the cosine is always the leg attached. The leg, not the hypotenuse, the leg. There's only 2 sides that make angle A. The leg that's attached is called the adjacent side, B, over the hypotenuse. Adjacent means attached. So the adjacent leg over the hypotenuse is cosine. So anything that seems to have the word sine in it has a hypotenuse for the denominator. When it's actually sine, it's the opposite side over hypotenuse. When it's cosine, it's the adjacent side over the hypotenuse. The other one, I'm putting a dotted line here on purpose because this tangent guy, this guy called tangent, he's different from everybody else. I'm going to stick with angle A. The tangent doesn't involve the hypotenuse. It's only about legs. The tangent is the opposite over adjacent, which is A over B in this case. Opposite over adjacent. Now, do you remember that I told you that the hypotenuse is always the longest side? Then think about this with me. Does it make sense to you that sine and cosine will always be proper fractions? Because the hypotenuse is longer than either of the legs. But this could be a proper fraction or not, depending on whether the opposite side is longer than the adjacent. So this one can be greater than 1 or less than 1, but these are always less than 1. Okay? Furthermore, think about this with me. Well, let's try these. What do you suppose that the sine, I'll put it on here. What do you suppose the sine of B is? Yeah, so you get your eyes on that angle and you think sine, opposite. B over C. Because its definition is opposite over hypotenuse. What is the cosine of angle B? A over C, because with respect to angle B, that leg is attached. It goes on top. Hypotenuse on the bottom. What's the tangent of B? B over A. So I'm going to put a little dotted line here too. Notice that when you have the tangent of A, one of the acute angles is A over B. The tangent of the other angle will be its reciprocal. Has to be. Right? And these two guys switch places when you switch angles, because opposite, the one that was opposite here becomes the adjacent to angle B. So think about this with me for just a minute. I'm going to talk a little more vocabulary here. Everybody set? Okay, we'll talk vocabulary here a little bit. Does it make sense that if this is a right angle, that these two angles right here are complementary? Remember that from geometry? Complementary means adds up to 90. If there's 180 degrees to go around and you've used up 90, there's 90 left for these two to share. They don't always split it evenly, but there's 90 degrees for them to share, which means they're complementary. So take a look at this and look up here, and I'll point it out to you. The sine of A is the same as the cosine of B. It's also A over C. So think about this with me. Focus really tight on this. The sine of an angle is equal to the cosine of its complement. The sine of A is equal to the cosine of its complement, B. When I say it, I mean angle A. That's the it. The sine of an angle is equal to the cosine of its complement. Guess what? This co right here does not reference co as in co-captain or co-president or something like that, where people share authority evenly. The co on cosine is short for complement. The sine of an angle is equal to the complementary sine of its opposite. It's equal to the complement's cosine. Co stands for, reminds us that they are related because they are complements. So that's the CO part of complementary. Anyway, bunch of information about that. This is all stuff you were supposed to have learned in geometry. Does this seem familiar to you? What? Huh? Does this seem familiar? Yeah. Here's the stuff that won't seem familiar. There are not just 3 trig functions. There's not just sine, cosine, and tangent. Those are the ones we use the most. But there are 3 others. Secant, cosecant, and cotangent. That's what I'm going to show you today. That's new. It's not hard, but you got to get it straight in your head how they're related to each other. This one right here, sine, is related to cosecant. And that's how it's written. That's its abbreviation. It's pronounced cosecant. cosecant of the same angle, A, is equal to the reciprocal. It's C over A. In other words, hypotenuse over opposite. You don't have to memorize this. What you have to memorize is that sine and cosecant are related and they are reciprocals of each other. If you know what sine is, then cosecant, just tip it over. Whatever sine, that's cosecant. Cosine is related to secant. If it's of the same angle that we cosigned over here, which I'm doing here, I'm sticking with A, it's reciprocal. It's C over B. In other words, hypotenuse over adjacent. You don't have to memorize this, like I said. What you have to remember is that cosine and secant are related reciprocally. And of course, tangent and cotangent, those are the easy ones to remember because it's both got the word tangent in it. The cotangent of the same angle is going to be B over A, which is adjacent over opposite, if you want to memorize it, but you don't have to. I'm not going to do these bottom ones because you go to if you want to know what the cosecant is, all you have to remember is that cosecant's related to sine. So go find the sine and tip it over. And this is how you can remember what goes with what. I hope this will help you. Sine, the word sine doesn't have a co on it, right? There's no co on the front of it. But cosecant has a co. Cosine already has a co on it. Secant doesn't have a co on it. Tangent doesn't have a co on the front of it, but cotangent does. What I'm saying is that these pairs of reciprocals, in every pair, there's a cofunction and a not cofunction in every one. Sine is not, cosecant is. Cosine is, secant is not. Tangent is not, cotangent is. In every pair of things, there's a cofunction and a not. So sine, which doesn't have one, has a cofunction for its reciprocal. It's cosecant. Get used to the word secant. We all right so far? Okay. That information is all in your book in the core concept on page 462. It's not quite as well tied together as I did, but you know, whatever. I'm going to erase this now. If you want a picture of it, you better take a picture now. And if you don't, that's fine. This is how all these things are related. I'll get out of the way. You don't have to have me in it. I don't have to be an author of that. Anybody wants a picture of it, do it now. Because I'm going to erase it here in just a minute. If you don't want a picture, it's fine. I'm just saying it's going to go away because I got to stay on camera here. Everybody got it? Okay, here we go. Okay, now what I'm going to do is I'm going to go through the exercises, each section, and show you how to do what they're asking you to do, rather than do the examples in the book, because they're full of theory and stuff like that. I just want you to be able to apply what you just learned to do problems. So, if you're going to follow with me, you want to go to the exercises so you can see what it looks like and how I'm going to handle it. Okay, I'm on page 466 now. Okay, now we actually use trigonometry to find out missing information, and it takes a little bit of effort on your part. It says in the very first section, that's above number 5 anyway, not the vocabulary or concept check, but above number 5 it says, evaluate the trig function of angle theta. And that circle with a horizontal crossbar in it is a Greek letter T. That's pronounced theta. Okay? Theta. And if you were to look at, say, number 8, your eyes need to be focused on theta. They're not going to call it a letter now. They're not going to put a capital letter next to the corner there like I did up here. You've got to just look at the theta, at the angle that theta's in, and decide what the trig function value is. Now, with respect to theta, what is 3? Opposite, adjacent, or hypotenuse?
Opposite.
Opposite. What is 9? What is 9? Hypotenuse. And what is it that ties together opposite and hypotenuse? Sine. And so we know that the sine of theta is 1/3 because 3 over 9 is 1/3. We also know that, think about this, we also know that the cosecant is 3 because 1/3 dipped over is 3. But that's all we know unless we find that leg, the long leg there. How do we find that? Pythagorean Theorem. Excellent. So this is, because I need you to understand what the instruction said. It said, evaluate the 6 trig functions of angle theta. With the information that we have there, we can only evaluate 2 of them. Sine, which would be 1/3, and cosecant, which would be 3 over 1, or 3. Those are the only 2 we can find right now. To find the other 4, we got to know what that adjacent thing is. So we use Pythagorean Theorem. So I'm going to call that missing leg x. And so I'm going to have 3 squared plus x squared equals 9 squared. Y'all see what I'm doing? Okay, so this is 9. You can write it. You don't have to write this down. If you can square these as you write them, that's fine. So it's going to be x squared equals 72. So x is the square root of 72, right? Now I got some bad news for you. You can't leave that the square root of 72. You have to simplify it by finding the pairs and bringing them out. So we take 72 and prime factor it in an effort to try to find the perfect squares that we can square root. 8 and 9 is the obvious one, I hope. 8 is 2 times 2 times 2. 9 is 3 times 3. There's a pair. There's a pair. And so this turns out to be 6 root 2. Because I brought out a 2. It's in that 6. I brought out a 3. That's the other part of that 6. And there was a 2 that didn't pair up, had to stay in. Do you all understand this simplification? Okay. So the remaining leg on this thing is 6 root 2. Now this is going to get nasty here pretty quick, so hang in here and look at the kind of work you're going to have to do. This was 3, this was 9. We just discovered this is 6 root 2 by applying Pythagorean Theorem. Now we have all the pieces. So we already discovered this one. The sine of theta is 1/3. The cosecant, and I suggest you do them side by side, so all you have to do is tip it over, is 3, which is 3 over 1. I'm just going to call it 3. We don't put things over 1. Okay? What is the cosine of theta?
Oh, that would be the square root of 72 over 9.
What did I hear? What would it be?
The 6 square root of 2 over 9.
Yeah. 6 root 2 over 9 because cosine is adjacent to the angle over hypotenuse. However, that can be reduced. What is it?
2 over 3. 2 square roots of 2 over 3.
Right? Knock a 2 out of both of those. 2, 3, 3. 3 out of both. This is how they expect it to be recorded. Now wait till you see how gross this is going to get. Secant of theta is what? At least to start with.
9 over 6 root 2.
I'd go with this one. I'd go with this reduced one. 3 over 2 root 2, right? Let me see if they need you to rationalize it. I'm not sure they're going to do this to you on a... Yes, they are. Okay. You cannot leave a radical in the denominator and have it be proper. What do we have to do to rationalize the denominator? You guys have forgotten. You got to multiply by root 2 over root 2, which is 3 root 2 over, now watch out here, this root 2 times this root 2 is 2. Times that 2, 4. That's what secant is, 3 root 2 over 4. So this isn't just simply remembering how they're related and writing something over something else. You got to do all the simplifying, got to rationalize denominators, cancel things where you can. It's a little rougher than you think. What is the tangent of theta?
3 over 6 root 2.
Good. 3 over 6 root 2. Before I rationalize the denominator, what does that simplify to?
1 over 3 root 2.
1 over 2 root 2. If I rationalize that, what do I have to multiply by? Root 2 over root 2. And that gives me root 2 over. Yep, that right there is 2 times that 2 is 4. So that's the answer to tangent theta. I don't have enough space over here, so I'm going to do it down here. What is the cotangent of theta? Where are you going to start? Listen carefully. If it were me, because I know I don't know what to expect on these things, I would not use this version of it, because as soon as I tip it over, I've got an irrational in the denominator, right? Use this version. Because if you tip that over, you get 2 root 2. See what I mean? So look at your versions, your simplified versions, and tip them over until you get one that's easier to deal with. This one right here, if you tip it over, it would work. It would give you 4 over root 2, but then you'd have to multiply by root 2 over root 2 to rationalize the denominator, which would be 4 root 2 over 2, and then you'd have to cancel for 2 root 2. Whereas this just gets it to you if you go right here. Just flip that over. So if you're a little bit clever, you can get to this a little quicker without having to rationalize. You can get there, but it takes a little more effort. If you go to the very end and tip that over, now you got an irrational denominator. Go up the line until you've got something that if you tip over, especially if there's a 1, you tip that over so that the numerator, which is rational, is now in the denominator. You don't have to rationalize it. So, just saying, be clever about what you tip over. That's how you do the ones from 5 to 10. Now, so you're going to have to find the remaining side using Pythagorean Theorem, and then focus your eyes on theta and find all 6 trig functions in simplest radical form. That's what these are on the end. These are simplest radical form. That one doesn't have a radical in it. It's still simplest radical form. This is simplest radical form for that. So is this. And this is for tangent. Nope, I lied. It's not that one. It's this one. And this is simplest radical form for cotangent. Fun stuff. Okay, that's how you're going to do those 6 numbers right there. And then, and by the way, number 8 is a sign. If you want to get a picture of this, you'll have it done. This is number 8, and it's part of your assignment. If you wanted to take an example, and hopefully you'll be able to figure it out. Everybody got what they need? Yeah? Here we go. On to the next one is similar to this, but you got to draw your own picture. They're not going to give one to you. So, take a look at the information or the problems that are above number 13. Well, 13 through 18 is what I'm talking about. And I want you to look at the instructions above, 13 through 18. It says, let theta be an acute angle of a right triangle. Okay. Evaluate the other 5 trig functions of theta. So they're going to give you 1, but they're not going to give you a picture. And you got to stick theta in one of the acute angles. So just get yourself a triangle drawn. Don't expect it to be to scale. So don't expect it to look just perfect. Just get yourself a triangle drawn and put theta in one of the acute angles. I'm going to put mine there. You can put yours down there. It doesn't matter. Then take a look, for example, at number 17. Are you looking? Number 17's information says the secant of theta is 14 over 9. Without filling out this picture at all, we now know what the cosine is. Because cosine and secant are related to each other. What's the cosine of this theta? 9 over 14. Most people remember this relationship better than this one. So that's the reason why I went to here first. I know the cosine is the reciprocal of that, 9 over 14. So when I come over here, here's theta. The cosine is 9, adjacent side, over the hypotenuse, 14. So you got to fill in your own information about that 9 over 14. You see what I did? Then use, just like we did in 5 through 8 or whatever that was, 5, that section with 5 in it. Once you've drawn this based on either this or this, depending on what you remember, we got 2. If they give you 1, you've actually got 2 if you remember the reciprocals. Put it on here where it goes, then use Pythagorean Theorem to fill in the gaps. This is, I'll call this x for right now. It's going to be 9 squared plus x squared equals 14 squared. That's 81 plus x squared equals 196. That's x squared equals 115. So x is going to be the square root of 115. So we take 115 over here on the side, prime factor it. We know 5 will go into it. What would that be? 23 times? That look right? Yeah, 23 times. And so, since this is prime and so is this and there's no pairs, we will just stick with the square root of 115. Did I do this arithmetic right? 196 minus 81, is that 115? I think it is. Yeah? Okay, so we got 115 out of that. We tried to prime factor it. We did prime factor it. However, they're both prime. There's no pairs. Nothing's coming out. So we leave it square root of 115. That's nice. Okay, so this is the square root of 115. Now we got to find the other 6 or the other 4 trig functions. I'm going to start here with sine. Now that I have it all filled in, I know that's backwards for anyway. I'm going to do the sine next. The sine of theta is going to be the square root of 115 over 14. Because it's opposite over hypotenuse. And there's no rationalizing to do. Happy day. Cosecant is next because it's the reciprocal. Cosecant of theta is going to be 14 over the square root of 115. Gross. Can't leave it like this. So we multiply top and bottom by the root 115. And it's not as bad as you think. That's 14 root 115 over 115. Because this times this, and this is on the outside, this is on the inside. They have to stay separate. But this times this is 115. That's why we did it. So we're done. Unless 14 will go into 115, which it won't. Or 7 or 2, neither one of those. I mean, there's a 7 and a 2 in 14, but there's no 7 or 2 in 115. We knew that because it was 5 and 23. I mean, 2 and 23. 5 and 23. Okay, so now we got to do the other 2, tangent. What's the tangent of theta? Well, tangent of theta is opposite over adjacent, which is the square root of 115 over 9. Rational denominator, things are good. Cotangent is going to be 9 over the square root of 115. Without writing this part down, do you realize that's going to be 9 root 115 over 115? Would you agree with that? 9 is made up of 3's. 115 is made up of 5 and 23. That's not going to reduce. So that's it. Ugly, but correct. Sorry, that's what it's going to have to do. So on this set of exercises, they're going to give you a fact, just one fact. You got to get yourself a triangle drawn, put that 14 and 9 where it belongs, either based on this, remembering that this is hypotenuse over opposite, hypotenuse over adjacent, or go to your reciprocal and put your cosine in. This is adjacent over hypotenuse. Pythagorean theorem, use this. Pythagorean theorem, this. Simplify this as much as possible before you put it on here. Go after the others. Kind of a lengthy process. But you guys are skillful. You can handle it. Okay, then when you get to the number or the exercise is just above number 21. Are you looking with me there? I don't know if any of you want a picture of this. This is number, or before I erase it, this is number 17. If you're interested, this was number 17. It's also a sign. Get out of the way. Or you can also go to the video and get it. Yeah, it'll be there. Okay. So we're actually going to use trig to find some missing elements. This is where trigonometry can be extremely useful in all kinds of applications. There we go. This is where you're going to need your calculator. And if you have your calculator, you are going to want to make sure that it is in degree mode. So you hit the mode key, which is right, just to the right of the blue key. You go to mode. And I can't remember how far down you go.
Just down. It's on the 3rd row.
It's in the 3rd row. Highlight, use your navigation arrows to highlight degree and make sure you hit enter. Because if you're in radian mode, you'll get all these wrong. Okay, need to be in degree mode. Okay, so on the exercises from 21 to 26, all of those are assigned as well, by the way. So the one I'm going to do is also required. I think I'm going to do number, Pretty sure they want these in radical form. Let's see. No, they don't. Okay. You do 21 to 26. There's a better way to do those, but I don't want to take the time to teach it to you because it's Friday, and you can do these, all of these with trigonometry anyway. So I'm going to do number 24. This is what they got. They've got a triangle like this. They've got a 30-degree angle here. They don't actually have it written like I do, but that's because they didn't have room. And then they've got one other thing, no, two other things. They've got an X and a 13. And our objective is to find X. Okay? So what you've got to do is, you got to take the angle, the side you know, and the side you'd like to know, and figure out which trig function relates them. And it will always either be sine, cosine, or tangent. You're limited to these three when you're trying to solve for X. You could use the others, but you don't have a button for it, so you might as well not. What is it that relates that angle 30 with that X and that 13? Which trig function?
The sine of A, I guess, right? Sine.
Wouldn't it be sine? Because with respect to this angle, we would like to know the opposite, and we do know the hypotenuse. So you have to ask yourself, opposite, hypotenuse, what is that? Sine. So it's sine. So we're going to say the sine of 30 equals X over 13. Does that make any sense to you? Based on the definition? Yeah? This is the kind of problem you're going to have where they're going to make you find something in the triangle that's missing. And you got to first figure out which trig function relates them together based on the definitions. By the way, have you all seen this? This is just a thought. I should have introduced it before. Have you ever seen this or heard somebody say it? SOHCAHTOA. That's how you say it. But if you can't remember how to spell it, it's useless. This is what it means. This is what it's supposed to be an acronym for. Sine is opposite over hypotenuse. That's what that means. That's for sine. This is opposite. This is hypotenuse. You with me?
Yeah.
Cosine is adjacent over hypotenuse. Cosine, adjacent, hypotenuse. That's what those three letters stand for. Tangent is opposite over adjacent. So this is your tangent. All of the first letters are sine, cosine, and tangent. The next two letters are numerator and denominator for the ratio definition. Are you with me there? So when you try to decide what this is, first of all, with respect to the angle, figure out the two things that you have. We have an opposite and we have a hypotenuse. This one's not involved. So what's opposite and hypotenuse? Sine is. That's why we chose this. Everybody clear? All right. Now you treat this like a proportion because the sine of 30 is just a number that your calculator knows. You may not know it, but your calculator does. Put that over 1, and now multiply it. We take this times this equals this times this. Now, why did I put the 13 on the front? Because if I didn't, you'd wonder, is it 13 before I sign it, or do I sign 30 and then multiply that by 13? When there's when the way you write it could lead to two different meanings, you don't write it that way. I put the 13 on the front. It's clear now I want to sign 30 and then multiply by 13, or 13 times the sine of 30. You understand why I stuck it on the front? And furthermore, in the cross multiplying, I isolated x. X is already all by itself. All I got to do is this calculation. Do it. 13 times the sine of 30. And by the way, when your calculator does it, you can put 13. You can just type sine right next to it. It'll slap down a parenthesis. Put your 30 in there. Make it a habit to close that every time. What do you get? 6.5? Okay, that's the answer to that. We okay on that? So first decide what links the two sides together with respect to the angle. Which one of these three things? Write it down, make it a proportion, cross multiply. And continue working on it till x is isolated. Because see, if x were down here, like for example, just as an example, this isn't related to this at all. If I said the cosine of, I don't know, 45 was equal to 9 over x. Then when you cross multiply, you're going to get x cosine of 45 equals 9, and x is not isolated yet. You got to go one more step before you do it, and it's a division instead of a multiplication. So you got to keep working it through after you cross multiply. If x is not already sitting by itself on one side like it was here, you got to continue and then do that calculation when this stands alone. You see, there's one more step. If x is in the denominator, when you write the relationship down, if it's the hypotenuse, if it's cosine and the hypotenuse is unknown, then you got one more step to isolate the x, and it turns out to be a division instead of a multiplication. So follow through. Okay, that is number 24. If you want to take a picture of that, I don't know if you do, but you might. So you don't have to watch the video. And 24 is also a sine, so there's another one done for you. Okay. All right, next set says, evaluate the trig function using a calculator, round your answer to 4 decimal places. That's a plug and show. Except when you have to do something like 29. We're going to do 29 for you, because it says cosecant of 59. You're going, well, crap, I don't have a cosecant button. Look at your calculator. There is no cosecant button. So how do you evaluate cosecant? Cosecant, oops, it's cosine. Cosecant of x, I'm sorry. Cosecant of 59, wasn't it? That's what we're trying to do? Well, we don't have a cosecant button, but we have a button that's related to this. What's related to cosecant? Sine. So this is the same thing as 1 divided by the sine of 59. It's an entire reciprocal. Cosecant and sine, the entire function. It's not just what they're equal to that's reciprocal. It's that the cosecant is equal to 1 over sine. They are reciprocals, the whole thing. So you're going to go 1 divided by the sine of 59. If it's cosecant, you want to evaluate. What is that? 1 point what?
1.16663.
Okay, so there's a 3 following this. They want it to 4 places, so you look at this 5th place, and it was a 3. It's not enough to bump that up, so this is what we write. Okay? So if you're doing one of the weirdos that's not sine, cosine, or tangent, figure out, remember which one it's related to, and just do 1 over that one that's familiar that you have a button for, because they're reciprocally related. Everybody clear? Next set, which is 33 to 40. This is going to get involved. It says, solve triangle ABC using the diagram and the given measurements. To solve a triangle means find all the missing pieces. Find everything about it that's missing. How many parts does any triangle have? 6. 3 angles, 3 sides. You've got to find, they'll always give you 3 things, one of them being a right angle. They'll always give you 3 of those, and you got to find the other 3. So they give you that triangle, all of them, and it looks like this. It's kind of like what I had before. A's up here, B is here, so A is here, B is here, and C is here. This is the triangle we intend to use, and I already told you the scheme and how they put things together. So take a look, for example, at number 38. In 38, it looks like they only gave you 2 things, but the right angle is always good. So they always give you 3 things. Right angles are understood, and then capital B is 31, and little a is 23. Capital B is 31, little a is 23. That's all you get. Which means that this is our list of things we got to find. We got to find angle A. Remember that symbol from geometry? That's the size of angle A. We also have to find little b and little c. Those are the 3 things that are missing. Because I have a side, and I have an angle, and I have this angle. I need 2 sides and the other angle. The other angle is the easiest one in the world to find. Because remember, we told you that A and B have to be complementary? So what is A? 59? Okay, that's the easy one. So if I were you, I would put that in here. You can use that now if you want. If you need to, you can use that. What would you do to find little c now?
Wait, hold on.
I heard somebody say sine. Sine of what?
Sine of. No. Sine of.
Sine of a, wouldn't it be? Because
Yeah,
if you're gonna try to find something, if you're gonna try to find one of the missing sides, you have to involve a trig function that uses this side somewhere. So you could either use the cosine of 31, which would be 23 over c. You could use the sine of 59, because that would be 23 over c. You could use the tangent of 31, because that would be b over a. You could use the tangent of 59. That would be 23 over b. We've got to go after either b or c. I'm going to go after c first. Now, you said sine. If you're going to use sine, you better use this angle, because it gives you this one over that. If you're going to use cosine, you better use this angle, because that would be 23 over c. See what I'm saying? You decide, but that's the reason why it's kind of nice to put the 59 there, because then you got options. So I'm going to say the sine of 59, you don't have to do that, it could have been the cosine of 31, equals sine, if that's what I'm using, of 59, this is the angle I'm focused on, is opposite over hypotenuse. You see what I wrote? You sure? Everybody clear on the decision? We make a proportion out of this. I'm not going to do that. This is over 1. So it's going to be c sine of 59 equals 23 in the cross multiplying. And we have an isolated c, so we got one more step. C is equal to 23 over the sine of 59. Now you calculate. And not until. You never pick up your calculator until you have the variable you want isolated, algebraically. Then pick up your calculator and do that calculation. Can somebody tell me what it is to the nearest? Did they tell us? No, it doesn't say. So you get your choice. Generally, the nearest hundredth is acceptable.
26.8.
That was C, 26.8. Should we put 26.8 right here? I recommend you don't. And the reason why is because this isn't really 26.8. It's 26.8 something. A whole bunch of other crap, right? Don't use this as part of your next calculation unless you absolutely have no other choice. You want to use whole numbers that are given to you to find the remaining thing. It's okay to approximate this when you're reporting the answer, but don't use this number that that's an approximation in your next calculation, or you may get it so far off you'll miss it, especially if you're doing big ideas. You with me there? Try to always use, if possible, try to always use the numbers that they gave you. The reason why I was able to use this one is because that wasn't an approximation. That's exact, isn't it? So this one's available for use. This one is not. I wouldn't use it. So how can I use one of these two angles and this 23 to get at B? What function? Oh, I heard cosine. Cosine of what? Never, never, never of a side. Cosine, sine, tangent, secant, cosecant, cotangent, they are always of an angle. Do you want to use cosine here?
I would say a C.
Yeah, cosine of 31. Right?
Cosine of, okay, if we use cosine of 31, what would that be?
3 over hypotenuse.
Which is?
C.
We already found C.
So yeah, if you do the sine, you could do the sine.
Don't use cosine. We already found C.
You do the sine of 31.
You want to do the sine of 31? Okay, the sine of 31 would be cosine of 31, or sine of 31 would be what?
B over 23.
Yeah, and now we're forced to use that approximation. Don't do that.
Oh, so you want to
Choose something else that involves B and 23. Tangent of what?
tangent of 31.
Tangent of 31, that equals B over 23. Could we also, I'll proceed here in just a minute. Could we also have done the tangent of 59?
Yes.
If we did that, what would that look like? 23 over B? Is there one that's better than the other as far as calculation goes? Not really. But there is one that's better than the other as far as steps. Because look, if I use this one, it would be 23 tangent 31 equals B. Done. Just calculate. If I use this one, it would be B tangent 23 equals, I'm sorry, tangent 59. 59 is never of a side, sorry. 59 equals 23, and then I got one more step. B would equal 23 over the tangent of 59. Which one's correct? They're both correct. This one's quicker. I'm not saying take a long time to try to decide, because now you've wasted the time you would have saved on this. I'm just saying, if the denominator is a known number, your calculation will be quicker. That's all I'm saying. Okay? So 23 tangent 31 is what? $13.8. Okay? Does that seem right? The hypotenuse is the longest. B is a little shorter because it's opposite the smaller angle, so it's going to be a little shorter than A, and that looks right. Yep. Okay. This is what you, and if it's in big ideas, they better tell you what to round to. So round to what they say so you get the right answer. That's called solving a triangle. And that one is number, I don't remember which one.
38.
38. This is number 38 if you are interested in a picture, because it's also part of your assignment. Okay. The rest of these are story problems, and the bell's about to ring, but let me just tell you this, listen. Angles of elevation are where you're looking right straight out parallel to the ground, and you have to raise your eyes up to look at something. That angle made by my arm is called the angle of elevation. If you're standing on a cliff and looking down at a boat, then right parallel to the water, the angle made, you have to open up to look down, because your line of sight goes down. That's called an angle of depression. Just a minute, those of you doing it on paper, here it is. 4 through 45. Yes, every dang one of them. 4 through 45 and 49. Do the best you can over the weekend. We will talk about your questions on Monday. 4 through 45 and 49. Anybody that's listening, see you. Bye.